Chapter 8 Discrete Random Variables. In this tutorial, we are going to construct a probability distribution for a discrete random variable given its cumulative distribution function. So we will work in an opposite way of the previous exercises. We will have a cumulative function and we need to obtain the probability distribution. Look at this exercise. A discrete random variable has a cumulative distribution function f of x given in the table. We have the observed values for the random variable. They are from 0 to 6, and for each value we have the cumulative function that is corresponding to it. Part A, draw up a table to show the probability distribution x, which is capital P of capital X equals to x. Then we will solve part B and C. For part A, we need to add a row which is probability of capital X equals to x. Let's recap the definition of the cumulative distribution function. We know that f of x is probability of capital X less than or equal to x. First, we have f of 0. What is f of 0? It means probability of x less than or equal to 0. Look at the table. Do we have a value less than 0? No. So it is the same as probability for 0. So the probability of x when it is equal to 0 is the same as f of 0. Our conclusion is that f of 0 equals to probability of x equals to 0. Pay attention that always in the first value, the value of f of x is equal to the value of the probability distribution. So in the first value, if f of x is 0, therefore the probability is 0. Okay, now for f of 1. We know that f of 1 is probability for x less than or equal to 1. Look at the values on the table that are less than or equal to 1. We have the 1 and the 0. So it is probability of 0 plus probability of 1. Probability of 0 is the same as f of 0. So f of 1 is f of 0 plus p of 1. Now we calculate p of 1. P of 1 is f of 1 minus f of 0. So we get rid of the value of the cumulative here. Probability for x equals to 1 is f of 1 minus f of 0. So 0.1 minus 0, the answer is 0.1. Okay, now for f of 2. It is probability of x less than or equal to 2. Using the table, this is the probability of values that are 2 and less than 2. So, probability of 2 plus probability of 1 plus probability of 0. We need to find probability of 2. If we add probability of 1 and probability of 0, we will get f of 1. So we will write plus f of 1. Therefore, the probability for x is 2 is f of 2 minus f of 1. If you look at the relations, notice that f of 0 is the same as probability of x equals to 0. Probability of 1 is f of 1 minus f of 0. Probability of 2 is f of 2 minus f of 1. Let's calculate it. F of 2 is 0.2 minus f of 1, which is 0.1. So the probability here is 0.1. Now we have a general rule. Notice that whenever you calculate a value, it is the f of the value minus the cumulative function of the value before it. So the probability for 3 is cumulative function of 3 minus the cumulative function for the value exactly before it, which is 2. This is our general rule. We subtract from the value of 3 the value of 2. So here we have 0.45 minus 0.2. The answer is 0.25 and so on. Okay, now for the probability of 4, it is f of 4 minus f of 3. F of 4 is 0.5 minus 0.45. The answer is 0.05. Probability for 5 is f of 5 minus f of 4. So 0.9 minus 0.4, the answer is 0.4. And finally, probability of 6 is f of 6 minus f of 5. So 1 minus 0.9, the answer is 0.1. So we calculated the probability distribution by using the function and the definition of the cumulative function, and by subtracting the values. Thus, now we can directly solve it with the general rule without the need to repeat the illustrations. We simply look at each value and we subtract the value of f from the function before it. Okay, now we have finished part A. You can be sure of your answer by adding all the probabilities, and their sum should be 1. Now for part B, find probability of x less than 5. So it is the values that are directly less than 5. So we add the probabilities of 4, 3, 2, 1, and 0. Less than 5 means that 5 is not included. It is 4 and less than 4. So we can say probability of x less than 4 or equal to 4. This definition directly means f of 4. We do this so that we don't need to add all the values each time. The definition of the cumulative function is probability of x less than or equal to x. F of 4 is given, it is 0.5. This answer is correct, and you can be sure by adding all the probabilities from 4 to 0. However, using the f of 4 is much easier because we have less calculations. Okay, now for part C, we will also solve this by using f of x. Probability x is bounded between 2 and 5. The 5 is not included. Let's assume that here we have a number line. This is 2 and this is 5. And here we have the first value, which is 0. X is between 2 and 5, and the 2 is included. So we take all the values that are less than 5. That means probability of x less than 5. However, we only want the values between 2 and 5. Thus, we subtract the values that are less than 2. We want the 2, so we subtract the values that are less than 2. Here we write minus probability of x less than 2. Okay, now let's obtain this by using the cumulative function. We can say that it is the probability of x less than the biggest value, and since there is no equality, we write it as it is. Also, we need to remove what is less than 2. So, from 0 to 2, but we want to keep the 2. We write x less than 2 without the equality. Probability of x less than 5, we look at the definition in part B, it is the same as probability of x less than or equal to 4 minus probability less than 2. It is probability of x less than or equal to the value that is directly below it, which is 1. If we look at the cumulative functions, it is f of 4 minus f of 1. Therefore, f of 4 is 0.5 minus f of 1, which is 0.1. The answer is 0.4. As a recap, when we work with cumulative functions, the easiest way is to say probability of x less than 5, then we subtract the value that is less than the lower boundary. If we have equality, then we remove it, so as if we are working in an opposite way. If there is equality, then we remove it when subtracting. Or if there is no equality, then we add it when subtracting. So as you can see, it is simply the opposite. Then we define each one as cumulative function and we read the values that are on the table. When solving, it is best to use the values that are given and not the values that you calculated. Because when calculating the probability, you may have a mistake. And if you solved part B and C by using the wrong values that you have calculated, then everything will be wrong. That is why it is best to always go back to the definition and the given values.